Every year, IKEA moves billions of dollars of furniture across 6 continents. But the invisible weapon behind this empire is not Swedish design or low prices. It is empty air, or rather, the ruthless elimination of it. In 1956, one employee could not fit a table into his car. That single frustration sparked a system so efficient it reshaped global retail and quietly shifted the real cost onto you. In 1955, a powerful cartel of Swedish furniture manufacturers launched a coordinated boycott against IKEA, refusing to supply the young retailer because of its low prices. This pressure threatened to destroy the business, forcing founder Ingvar Kamprad to find alternative production sources and design his own furniture. The solution arrived the following year, in 1956, when IKEA's 4th employee, Gillis Lundgren, tried to load a leaf-shaped side table called the LOVET into his small car for a catalog photo shoot. Frustrated by the awkward legs, Lundgren realized he could simply unscrew them and lay the components flat. This single decision shrank the shipping carton to roughly 1/6 the size of the fully assembled table. Kamprad immediately recognized the commercial potential. By moving furniture in pieces, they could fit far more products into every delivery vehicle. This breakthrough established IKEA's war on shipping air, the empty, wasted space inside transport trucks. Instead of paying shipping carriers to transport empty air, IKEA could now pack dozens of flat-packed LOVET tables into a single truck, multiplying shipping density and turning a hostile industry boycott into a massive logistical advantage. What began as a clever loading trick quickly became an unyielding law of production. Every new piece of furniture had to fit into a flat cardboard sleeve, or it would not be made at all. This absolute rule found its ultimate expression in 1979, when range coordinator Vivian Scholin pushed to create an inexpensive, lightweight side table. The development team faced a strict constraint. The retail price could not exceed 75 Swedish kroner. To meet this aggressive target while ensuring the product could pack perfectly flat, the builders abandoned solid wood entirely. Instead, they borrowed a physical construction technique used for interior doors, creating a hollow board on-frame structure. This method sandwiched a lightweight paper honeycomb core between thin layers of fiberboard. The resulting table was strong, weighed under 10 pounds, and featured detachable legs that nestled flush against the underside of the main panel. The completed package measured only 2 inches thick. By engineering the furniture to fit the container, rather than wrapping a box around a finished item, the packing dimensions became the primary design brief. Product development and logistics merged into a single process, transforming the cardboard shipping carton from a post-production afterthought into the starting point of the entire manufacturing cycle. In 1979, IKEA introduced a product that would test whether this flat-pack logic could scale from a single side table to a massive global furniture catalog. This was the Billy bookcase. Designed by Gillis Lundgren, the simple bookcase became a global phenomenon, with more than 140 million units sold by 2023. The flat-packed box, measuring 81 inches long by 12 inches wide, was thin enough to be handled easily by forklift operators. The success of the bookcase relied heavily on its mathematical alignment with the cargo containers that shipped it. In 1988, IKEA engineers made a subtle design change. They reduced the bookcase's standard width from 90 centimeters to 80 centimeters. While this adjustment improved structural stability and prevented shelves from sagging, the primary driver was transport geometry. An 80-centimeter panel fit perfectly onto a standard European shipping pallet, measuring 1.2 meters by 0.8 meters. By eliminating overhang, this change allowed workers to stack dozens of flat-packed bookcases onto a single pallet. Under planned conditions, a standard 40-foot shipping container can carry 24 of these pallets. With 30 bookcases stacked flat on each pallet, a single shipping container holds roughly 720 bookcases. This container math radically altered the economics of retail. Shorter, narrower shelves meant more units squeezed into every truck, lowering the ocean freight cost per unit to a fraction of $1. By forcing the design of the Billy bookcase to conform to the precise measurements of global shipping crates, the company proved that transport constraints could dictate the shape of ordinary home furniture.
The math of the flat pack becomes even more consequential when applied to large, heavy bedroom furniture. A standard 6-drawer dresser normally occupies more than half a cubic meter of space during transit. For decades, shipping these bulky items meant paying carriers to move mostly empty air trapped inside pre-assembled drawers and frames. IKEA solved this structural inefficiency with the MALM series, proving that even massive bedroom suites could conform to the unyielding rules of the flat pack. Instead of shipping a giant, hollow wooden box, engineers collapsed the dresser into a series of thin, nested panels. The heavy side walls lay flat against each other, while detachable legs and modular drawer fronts packed flush within the same rectangular carton. To hold these heavy components together without permanent factory joinery, designers engineered knockdown construction using metal camlock fasteners. These small circular locks anchor steel pins embedded in adjacent panels, allowing a rigid structural frame to be built from entirely flat pieces. This engineering converts the dresser from a logistical challenge into a dense, stackable block. The flat-packed MALM box measures roughly 80 centimeters by 40 centimeters, allowing warehouse workers to stack 64 dressers onto a single pallet, layer by layer. By maximizing container space and eliminating the empty volume inside the furniture, IKEA reduces transport-related carbon dioxide emissions by approximately 30% compared to shipping the same items fully assembled. This massive environmental and financial savings, verified by life cycle assessments, proves that flat packing is not a product trick. It is the foundational architecture of a global logistics system, turning bulk shipping into a highly predictable, high-density science. The flat cardboard box serves as the direct handoff point between the automated factory floor and the home. Inside, the compressed panels require one last action to become functional furniture: human labor. By design, IKEA stops manufacturing just before the last step, shifting the physical work of assembly directly to the buyer. This unpaid labor is an essential component of the business model, delivered alongside a wordless instruction sheet and a small steel Allen key. This cheap, L-shaped tool connects mass production directly to domestic life. The brand experience is built around this physical process. By opening, sorting, and building the components, the customer becomes the finishing worker on the manufacturing line. Ownership grows through this effort, transforming a stack of flat boards into a finished household object. This system-wide optimization yields significant carbon savings on paper. IKEA reports a 25% reduction in average transport emissions since 2017, aided by the fact that roughly 70% of its packaging material is now renewable or recycled. Yet these logistics efficiencies do not erase the broader ecological footprint. Compressing transport volume demands a massive output of single-use corrugated cardboard, and the model relies on millions of individual customers driving private vehicles to suburban stores to collect their flat-packed goods. The emissions saved in ocean containers can quickly evaporate during this last-mile consumer commute. Ultimately, the flat pack operates as the core engine of an integrated machine, where product design, warehouse packaging, global logistics, and buyer assembly are engineered to function as a single system.
Today, as global logistics face rising environmental and economic pressures, IKEA's relentless optimization is no longer just a retail strategy, it's a global survival blueprint. When you build their furniture, you finish their supply chain. What's your take on this model? Let us know in the comments.